Hey, this is the video for 1.5, isotopes. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Also, check out the essential vocabulary. Today we will be discussing isotope and atomic mass. So isotope, iso means same, tope means place. Isotope basically means, for our purposes, it means it's the same element with different neutrons. In other words, it has the same place on the periodic table, but what's different is the neutrons. Okay? Now, I'm going to show you, we have there's many different isotopes of carbon. There are three main isotopes of carbon, two of which are found more often. We have carbon-12, which is the most common. That has 6 protons, 6 electrons, and 6 neutrons. If you notice, all three of the carbons all have 6 protons. All three of the carbons all have 6 electrons. Because once you change the number of protons, you're actually changing the identity of the element. So any element or any atom with 6 protons is automatically going to be carbon. And since they are neutral atoms, they are going to also have 6 electrons. So this bottom number right here refers to the atomic number, or the number of protons. The top number here, and this you need to remember, the top number refers to the atomic mass. And that again is the number of protons plus neutrons. So if you look here, 12 is 6 plus 6, 13 is 6 plus 7, and 14 is 6 plus 8. Carbon-14, even though it's not very, very common, it is found, it's like 1/trillionth as abundant as carbon-12. Carbon-12 is the most common. Carbon-14 is quite rare, but we use carbon-14 for dating organic material. Like if you had something that has gone extinct, like a woolly mammoth or any type of organisms from the last ice age that have gone extinct, you can determine the amount of carbon-14 that is present. And we'll be discussing this much later in the curriculum. Now, the way you can tell which isotope is the most common is by looking at this atomic mass. Notice it has decimals in it. This is because most of the carbons are carbon-12. That's why the average is closer to 12 than it is to anything else. So because this is 12.011, this is really close to 12. In fact, most of the carbon that's found is carbon-12. There's a little bit of carbon-13, a little bit of carbon-14, and other carbons that's actually altering that atomic mass slightly. So the way that this works, and this is what is similar and different, and you should pay attention to this. In fact, you should write it down. But we have the same between all these carbon isotopes. We have the same atomic number, we have the same protons, we have the same electrons, and we have the same properties. What is different? We have different neutrons, which gives us different atomic masses. Now the atomic mass, this is how you are going to calculate the atomic mass. On the reference table, you are given so many different formulas that you have to know, and those are on the back page of the reference table. However, this formula is not provided to you. You just have to memorize this one. So this formula, to figure out the atomic mass, remember the atomic mass, it's the weighted average mass of all of the naturally occurring isotopes. The Regents likes to trick people a lot, but basically it's an average, and it's only the naturally occurring isotopes. You could make many isotopes of carbon by just shooting little neutrons. It's not easy, but you could shoot little neutrons into the nucleus and you could bring this mass up. But if it's not a naturally occurring one, then it doesn't get calculated into this atomic mass. So the formula you want to use is the percent over 100, because that's how you do percent, times the mass of A, or one isotope A, and then you're adding the percent over 100 times the mass of isotope B, and so on and so forth. Sometimes you'll have like 3 or 4 different isotopes that you have to add up. That's why there's these ellipses. Write this down. This is important. Okay, here's how you solve one. So for our intents and purposes, now granted, I told you before that carbon-14 is like 1/1/trillionth of the abundance. That is so insignificant, it won't even factor up in this, but this is how you will solve this. 99% of the carbon that is found on Earth is carbon-12, about 1% is carbon-13. Now granted, these are going to be decimals, but for our purposes, this is how you solve it. So we would take 99 over 100 times 12, that's the atomic mass of carbon-12, and we're going to add it to 1 over 100, or 1%, times carbon-13. So when you do that, you're going to get 11.88 plus 0.13. And when you add these two up, you get 12.01. Notice 12.01, 12.011. The difference is basically rounding and, these were whole numbers. But essentially, this is how scientists calculate the atomic mass. You're going to be practicing. I want you to perform this check for understanding right now so I can gauge whether you understood this. I hope that this video was informative. I thank you for your attention, and I will see you soon.